Hello everyone, I am Dr. N. Kalachilvi, Assistant Professor from Department of IT at Fatima College Autonomous, Madurai. Now we are going to see firewalls in network security. This is the outline of my presentation, the nature of today's attacks, firewall definition, what firewalls can do and cannot do, and what are the types of firewalls. The nature of today's attackers. We can say there is a term called hackers who are trying to break into a computer. Most people imagine someone at a keyboard late night guessing our passwords to steal confidential data from our computer system. This type of attacks does happen, but it makes up a very small portion of the total network attacks that occur. And the second type of attacks, we can say worms and viruses. They initiate from vast majority of attacks. Worms and viruses generally find their targets randomly. As a result, even organizations with little or no confidential information need firewalls to protect their networks from these automated attackers. Then the definition of firewall. The term firewall has been around for quite some time and originally was used to define a barrier constructed to prevent the spread of fire from one part of a building to another. Network firewalls provide a barrier between networks that prevents or denies unwanted or unauthorized traffic. The definition of firewall is a network firewall is a system or group of systems used to control access between two networks, that is, a trusted network and an untrusted network, using pre-configured rules or filters. What is a firewall? It is a device that provides secure connectivity between networks. The networks, we can say it is an internal or intra-network, and then external or internet, used to implement and enforce a security policy for communication between networks. And firewalls can either be a software or a hardware. What firewalls can do? What are the effects of firewalls? We categorize the effects as positive effects as well as negative effects. Positive effects. We can say user authentication. The firewalls can be configured to require user authentication. This allows network administrators to control, track specific user activity, auditing and logging. By configuring a firewall to log and audit activity, information may be kept and analyzed at a later date. And the next one is anti-spoofing, detecting when the source of the network traffic is being spoofed. Anti-spoofing, detecting when the source of the network traffic is being spoofed, that is, when an individual attempting to access a blocked service alters the source address in the message so that the traffic is allowed. Next one, network address translation, changing the network addresses of devices on any side of the firewall to hide their true addresses from devices on other sides. There are two ways of network address translation is performed: one-to-one, many-to-one. One-to-one, where each true address is translated to a unique translated address. Many-to-one, where all true addresses are translated to a single address, usually that of the firewall. Virtual private networks, VPNs, are communication systems traversing public networks that have been made virtually private through the use of encryption technology. And VPN sessions are defined by creating a firewall rule that requires encryption for any session that meets specific criteria. Negative effects. Although firewall solutions provide many benefits, negative effects may also be experienced. First one is traffic bottlenecks. By forcing all network traffic to pass through the firewall, there is a greater chance that the network will become congested. Next one, the single point of failure. In most configurations where firewalls are the only link between networks, if they are not configured correctly or unavailable, no traffic will be allowed through. Then increased management responsibilities. A firewall often adds to network management responsibilities and makes network troubleshooting more complex. A firewall cannot and does not guarantee that your network is 100% secure, and a firewall cannot offer any protection against inside attacks. Firewalls cannot provide protection against viruses or malicious code, as they are not aware of any threat that may be contained inside a packet. Finally, no firewall can protect against inadequate or mismanaged policies. How firewalls work? There are two design logic approaches network firewalls use to make access control decisions. First one is everything not specifically permitted is denied. Everything not specifically denied is permitted. The one most often recommended is everything not specifically permitted is denied. Here is the basic flow of how firewall works. Here we have given a sample IP packet. It contains IP header, the protocol header, and then the segment of a message. IP header contains the source IP and destination IP addresses, and the protocol header, either it is of TCP header or it is of UDP header. It contains the source port and the destination port, and followed by the message segment. Now we are going to see what are all the types of firewalls. The firewalls types can be categorized depending on the function or methodology the firewall use, whether the communication is being done between a single node on the network or between two or more networks, and then finally whether the communication state is being tracked at the firewall or not. By the firewalls methodology, we are categorizing the firewalls into the following 5 types: packet filtering, stateful packet inspection, application gateway proxies, adaptive proxies, and circuit level gateway. So we are going to see what is packet filtering firewall. A packet filtering firewall does exactly what the name implies. It filters the packets. Incoming as well as the outgoing packets are being filtered by the packet filtering firewall. As each packet passes through the firewall, it is being examined and information contained in the header is compared to pre-configured set of rules or filters by the firewall, and an allow or deny decision is being made by the firewall by comparing the results of the packets examination. Each packet is examined individually without regard to other packets that are part of the same connection. So here is a logical diagram of a packet filtering firewall. There is two types of networks: trusted network and untrusted network. The packets are being passing from trusted network to the untrusted network via the firewall. The firewall checks each and every packet from the trusted network, and then it decides whether to block or discard any packet or to allow the packet to go to the untrusted network. A packet filtering firewall is often called a network layer firewall because the filtering is primarily done at the network layer, that is the third layer, or the transport layer, that is the fourth layer of the OSI reference model as shown in figure here. You can use packet filters to instruct a firewall to drop traffic that meets certain criteria. For example, you could create a filter that would drop all the ping requests coming to the firewall at a certain point. Packet filtering rules or filters can be configured to allow or deny traffic based on one or more of the following variables, like source IP address, destination IP address, protocol type, whether it is a TCP or UDP, source port, and the destination port. The strength of packet filtering is the packet filtering is typically faster than other packet screening methods because packet filtering is done at the lower levels of the OSI model. The time it takes to process a packet is much quicker. Packet filtering firewalls can be implemented transparently. They typically require no additional configuration for clients. Packet filtering firewalls are typically less expensive. Many hardware devices and software packages have packet filtering features included as part of their standard package. And then Weaknesses of packet filtering. Packet filtering firewalls allow direct connection to be made between the two endpoints, that is the trusted and the untrusted network. Although this type of packet screening is configured to allow or deny traffic between two networks, the client or server model is never broken. And then the next weakness of packet filtering firewall is they are fast and typically have no impact on network performance, but it's usually an all or nothing approach. If ports are open, they are open to all traffic passing through the port, which in effect leaves a security hole in your network. And then defining rules and filters on a packet filtering firewall can be complex task. The proxy pays middleman in all connection. Now we are going to see application gateways or proxies. This type of firewall operates at the application level of the OSI model. For source and destination endpoints to be able to communicate with each other, a proxy service must be implemented for each application protocol. The gateways or proxies are carefully designed to be reliable and secure because they are the only connection point between the two networks. Here it shows the typical diagram for application gateways, which acts in the application layer of OSI model. When a client issues a request from the untrusted network, a connection is established with the application gateway from the client. The proxy determines if the request is valid by comparing it to any other rules or the filters, and then sends a new request on behalf of the client to the destination. By using this method, a direct connection is never made from the trusted network to the untrusted network, and the request appears to have originated from the application gateway proxy. So this is being shown here. Here is the workstation, and the application gateway is in the middle, and there is untrusted network. So the client or the workstation tries to communicate to the untrusted network. So it establishes a connection to the application gateway or the proxy server. The proxy server checks whether the client validates the client's request, and then it creates its own connection to the untrusted network. So there is no direct connection or the communication between the client and the server. Conclusion: don't make the mistake of thinking that no one will attack your network, because with the rise in automated attack tools, your network is as much at risk as every other network on the internet. The need of firewall has led to their ubiquity. Nearly every organization connected to the internet has installed some sort of firewall. When choosing and implementing a firewall solution, make a decision based on the organization's need, security policy, technical analysis, and financial resources. Solutions available today utilize different types of equipment, network configurations, and softwares. Thank you.